Bop. Hey guys, welcome back to another video, and today I'm going to be talking about factoring. Factoring is the most important skill in algebra, and if you can factor, you can simplify. You can do literally anything. You can solve equations, you can work with fractions. Very important for calculus if you're going to take it pre-calc. It's one of the things a lot of people struggle with, but today I'm going to teach you almost everything there is about factoring. So what is factoring? So if you recall, what I'm showing here is, if you heard a FOIL, if you were to FOIL out these two binomials, a binomial is just x plus something within parentheses. If you FOIL out these two binomials, because remember FOIL stands for first, outer, inner, last, you'd get this term right here, whatever this is. It's a quadratic equation. Now, how can we go in the other way? If this was expanding, how can you condense? And that's factoring. In FOIL, you multiply. In factoring, you divide. Not people know that, but they're actually inverses of each other. So let's think about it. If I gave you something like x squared plus 5x plus 6, how could I get, let's think about factoring. How can I get the two binomials that will FOIL out to give us this? How can we do it? Well, there are a lot of ways to do it actually, and it's not as straightforward as FOILing, but once you do it and you practice a lot, it starts to make sense. So here we go. Now there's a definite answer that I'll talk about at the end of the video, but I want to start off with saying factoring, basically, when you're doing it, it's a combination. It's a combination of two numbers. I mean a combination of two numbers. For example, the general form of a quadratic equation is ax squared plus bx plus c equals 0. Remember, when we factor, you have to set whatever we're doing equal to 0 so we can factor. And I'll get into the reason as to why later. Anyway, a, b, and c are all numbers. A and b are specifically coefficients of variables, and c is a constant. Here we have our a would be 1, our b would be 5, and our c would be 6. So why am I saying this? Because the only way to factor in this case is something called the a times c. You might have seen it something like this: a times c and b. So what does that mean? You have to times the a and the c term, so it'd be 1 times 6, which is 6, and they have to add to 5. Okay, so you have to have two numbers that times to a times c, but also at the same time have to add to b. What does that mean? It's two numbers that they're doing two operations with. You're multiplying and you're either or adding or subtracting. What does that mean? Okay, here. What are two numbers? What are two multiples of 6? Because 1 times 6 that we know will times to 6 but will also add to 5. Well, 3 and 2. You can do 3 times 2 and you'll get 6. You can do 3 plus 2 and you'll get 5. That's it. Literally, that's it. Now from here, all we do is we write the factors out like this: x plus 3, x plus 2. And we can always FOIL check our work. We get first, outer, inner, last. And if we... That's it. That seems really complicated, but it's really not. Let's go through another example. Okay. Let's start off a little easier here. So we have something like 6. Let's give you this example. 6x cubed minus 9x squared. Okay. So with factoring, I just gave you an introduction, but I'm going to actually start off with the many rules that there are because they build on each other. I was just showing you just to at least show you what's happening here. But the number one thing you want to do to make your factoring easier is to try and factor out. Factor is another word for dividing, or if you think of it as taking away, is to use the greatest common factor. Greatest common factor is the largest thing we can take out of this. Okay? So it's in order to do this, all the terms in here, whether it be a 2-term or a 3-term, they all have to have something you can take out of. Okay? What does that mean? Think about it here. We both have x's here, right? We have an x cubed and we have an x squared. Okay? So the x cubed has an x squared in it because it's x times x times x. And the x squared has x times x. Okay? So if we think about it logically and we take out an x squared, okay? Think about it like this. Then what does it become? This is in factor notation. You take out x squared. Well, it just becomes 6x. Because remember with properties of exponents, if we divide an exponent, if we do x to the third, divide by x to the second, we subtract and we get x. Same, you can think of it like this, think of it like this. We took out an x squared, we divide by x squared, okay? And we lost 2 of the x's, 2 of the repeated x's from the x cubed, and we lost all of our x's from our x squared. Now what else can we do here? Remember with greatest common factor, it has to be something that everything in the equation shares. We took out the x's here. We can't take out any more x at this point because look, notice that 6x has an x but 9 doesn't. So we can't take out an x, but we can take out a factor. Like a factor, I mean something they can like be reduced to. We can take out a 3. Why? Because 6 divided by 3 is 2, and 9 divided by 3 is 3. They have to divide, the multiple you're using has to be something that they will both divide to become like integers. They can't be decimals. They have to share that. So if we take out a 3 from here, it becomes 3x minus 3. So then if we combine everything here, we get 3x squared, 3x, 6 divided by 3 is 2. Oops, sorry, I made a 6 divided by 3 is not 3. It's 2. 2x minus 3. So this is it. Okay, and we can prove this like again. If we FOIL out, we get we get 6x cubed minus 9x squared. It's a little, we're going to keep doing more problems. Okay, let's try another one. So, let's try negative 12x squared plus 18x. Okay. So you can pause right here and try it. Okay, let's go ahead and try this. So, I'm going to start off with taking what do these both share? These 18 divided by 3 is 6, and negative 12 divided by 3 is negative 4. So I'm going to start off with taking a 3 and the x, because they both can be they're both divisible by 3, and they will have an x, so we can take that out. So I'm going to take a 3x out. So now we get negative 4x plus negative 12 divided by 3 is 4, and 18 divided by 3 is 6. Okay. Good. Is this simplified? Let's look at it. So can 4 be reduced to something else? Yes. Can 6 be reduced to something else? Yes. So let's go back. Let's start over. We can continue, but I don't want to confuse you guys. Let's go back and let's take out something greater. Okay? What if we took out a 6? So we know 18 divided by 3, 18 divided by 6 is 3, and negative 12 divided by 6 is 2. Okay, that sounds better. Then let's do again. Let's take out x. So 2x, negative 12 divided by, I said 12 divided by 6. Oops, not 2. So let's take out 6x. So negative 12 divided by 6 is 2x. And then 18 divided by 6 is 3. And this is a negative in here. And if we FOIL out, we should get the same answer. Great. So if they told you something, factor this expression, this would be our factor. It would be this right here. Let's go do a couple more. Okay. 14x to the 4y minus 21x squared y cubed. Okay. Same idea. What can we take out of here? Right away, I'm thinking at this point, 21 and 14 can both be divided by 7. So let's take out a 7. They both have x's and y's, so we can take out x's and y's, but we have to take out the lowest amount. You have to take, remember, the greatest common factor. It means take out the max you can take out. The max we can take out is an x squared. So I'm going to take out an x squared, and I'm going to take out a y. Okay, so what does that leave us with? That leaves us with 7x squared y. 14 divided by 7 is 7x squared. The y divided by y is 1. Minus negative 21 divided by 7 is 3xy. Now let's distribute everything. So if we distribute everything, we get 14x4y minus 21x3. We take out, oops, sorry. Yeah, y3, take out y, and we get y3. So this would be the final answer. Okay. So this is the greatest common factor. And you always want to do this when you can take out something to make it easier. Do you know what I mean? But even then, like, even if you did this, sometimes you have to continue to factor, because this isn't something, it's very rare that you can just do this and you can get the final answer. It's more so you have to combine techniques. So this is called, just for reference, this is called the GCF factoring method. Okay, so let's try something else. So let's recall some identities. Okay, so the difference of squares, you need to memorize this, or we can derive it. And I don't like to memorize, so let's derive it. So this is the identity. A is B's are placeholders, so it's basically saying something squared minus something squared in a binomial will factor out to this, vice versa. And this is something, if you have familiarity with square roots and exponents, this makes a whole lot of sense, but I'm just gonna assume that we do. So here, let me give you an example. So how would we factor this right here? Well, we can apply the property, can we? So right away, I like to think of this as you can only do this with something that's a perfect square. Like if we had the square root of 48, that's an integer. It's a decimal. It's like a huge amount of numbers. But with 49, we know the square root of 49 is plus or minus 7, because anytime you square root a number, you get a plus or minus, because negative 7 times negative 7 is 49, and 7 times 7 is 49. Because remember, if we exponentiate a number, which means to raise it to a power, we're doing repeated multiplication. But if we're taking the square root of something, it's division in a way, because you're finding two numbers that give you this. It's not really division, but it's the inverse of squaring something. You're finding what two numbers can get to this number. So right away, if we apply this property, what you can do is solve for x. This is what I like to do. So if we solve for x as normally, and we take the square root, we get x equals plus or minus 7. And what I do is I just write the factors as is x plus 7, x minus 7, x plus 7. That's the trick. You won't ever forget this. I mean, you can memorize it if you want. If you memorize it, all you would do is just take this x squared minus a 49. You just copy an x, and you recognize that this is just a square root. 49 square root, it has a negative and it has a positive, so you just get this. You end up with the same answer. We can verify by foiling. Remember, with difference of squares, the b terms are always going to cancel out, and we get x squared minus 49, so it's verified. So, but then again, it's better to memorize the identity. I'm just showing you what works for me. So here's another one. So let's try 9x squared minus 16. So how can we do this here? So what I like to think about is always think about in terms of, square roots. Remember square roots. So right away, don't get confused. You're always going to have an x and another x. One's minus, one's plus. So right away from here, I'm going to write my factors out. I'm going to remember that the square root of 9 is 3. Okay? And I'm going to get an x. I'm going to copy an x. Square root of 16 is plus or minus 4. So minus 4, 3x plus 4. The only thing you really take the square root of is what's on the right of the minus sign. Recall that we don't really take the square root of anything on the left. We did technically, but we just did it just so we can get back to our factored form. So it really depends, but usually it's not that complicated. Like for example, if we did negative 4x squared plus 100, okay, or no, if we did it as 100 minus 4x squared, how would we factor this out? So right away, we can recall the square root of 100 is 10, and then we can just write it as such. So be sure to practice with these, and yes, this is called a difference of squares identity. So now let's move on to something different. Let's move on to perfect square trinomials. So this is technically not identity, but honestly you don't even need to memorize. You can just factor normally. The A times C method that we did in the beginning of the video, we're going to try it here. So let's try this. So x squared plus 10x plus 25 set equal to 0. Let's start factoring. So let's think about it. Let's label A, B, and C. Okay, remember, it's called A times C for a reason. We have to times our A and our C coefficients, and those whatever we're gonna do 1 times 25 in this case. So 1 times 25 equals 25, and we have our B equals to 10. So we need two numbers that time 25, okay? But those two numbers also have to add to 10. Okay, so right away, what do we know? The trick is to get 25 and to divide by every divisible number. So start. So 25 divided by 1. Okay? So 25 divided by 1 is 25. Okay? So when you're doing something like this, this and this are going to be your combinations. This is how I learned it. Okay? So let's try 25 divided by 2. So 25 divided by 2 equals 12.5. We can't use this, it's a decimal. Okay, 25 divided by 3, also a decimal. 25 divided by 4, also a decimal. 25 divided by 5, so let's do 25 divided by 5. This is a combination, this is a combination. Whoa, 1 second. So if 25 divided by 5 is 5, that means 5 times 5 is 25. So 5 times 5 is 25. But 5 plus 5 is always 25, so this double combination of numbers gives us our factors. Okay, so that means our answers are just simply x plus 5 and x plus 5. That's it. Okay, let's try another one. Or 1 second. I got something. We have two things like this. Since they're the same, we're repeating multiplication. You just do x plus 5 squared, because we're repeating it, the multiplication, because factoring is multiplication. Okay, so let's try this one. I want you to try this one on your own. Let's go through it. Equals to 0. So what two numbers times 36 but also add to negative 12? So think about it. So let's do, remember, our A times C. So 1 times 36 is 36. This is our A times C. And our B we're going to copy as is negative 12. Negative numbers. Ooh. Remember, we can have negative numbers sometimes. So let's go. Let's start combination. So let's do it. So get our number and start from the beginning. So 36 divided by 1 is 36. So 136, if we do 36 plus negative 1, we get 35. If we do negative 36 plus 1, we get negative 35. You can remember, you can always flip the combos, okay? Let's try. Okay, that won't work. So 36 divided by 2, let's try it. So 36 divided by 2 is 18. So you have 18. So 18 plus 2 is 20. 18 minus 2 is 16. No, it won't work. So you can always change the sign. That won't work. So let's try 36 divided by 3, which is 12. Okay. So 3 plus 12 is, 12 plus 3 is 16. 12 minus 3 is 9. Negative 3 plus 12 is, well, it's 9. It's the same thing as subtracting. So what if we did 12 divided by 4? Let's think about 12 divided by 4. Would that work? Let's try it. So 36 divided by 4. Oh, sorry. 30 divided by 4. So 9 times 4. So if 36 divided by 4 is 9, let's think about adding first. So 4 plus 9 is 13. And is that equal negative 12? No. So right away we don't know that that's the answer. So let's do 36 divided by 5. Let's see, is this an integer? This isn't an integer. So it's a decimal. So let's do 36 divided by 6. So 36 divided by 6 equals 6. Wait. These, remember, recall, everything we've did over here have been combinations that will give us 36. But they're not also combinations that will give us our b value. Because remember, when we're doing our b, they have to be it's a different operation. So here, what happens at this point? If we know 36 divided by 6 is 6, that means 6 times 6 is 36. Okay? We can do 6, with that logic, we can do 6 plus 6 is 12. Okay, but negative 12 and 12 aren't the same thing. Okay. If we know 6 plus 6 is 12, correct? That means negative 6 plus negative 6 is negative 12. But negative 6 times negative 6 is 36. Because remember, these combination numbers must be both for the a times c, the product of the a times c, and the sum of the b, which is right here, as is. So that means the factor over here right away would be x minus 6. X minus 6. Or alternatively, x minus 6 squared. Okay. Now we're going to work with more factoring, more trinomials. Okay, so let's try another one. X squared plus 7x plus 10 equals 0. So how do you factor this? Okay, so let's label again A, B, and C. So what two numbers time to 10 and add to 7? Okay. 10 divided by 1. Start from our C and go down. Our product of our A times C is go down. So this is 10. 10 plus 1 is 11. 10 minus 1 is 9. We can, and if we do the other way around, it's the same thing. It doesn't work. So let's do 10 divided by 2. Wait. That's 5. Okay. So if we 10 divided by 2 is 5, it means 5 times 2 is 10. And remember, our combinations are usually these two numbers right here. Always these two numbers right here. So that means 5 plus 2 is 7, but 5 times 2 is also 10. So that means our factor right here would be x plus 5 and x plus 2. Verified. Great. Let's try another one. X squared minus 3x minus 10. Okay, so let's do our A, B, and C. Let's times A times C. So we have a 1, always a 1 right here. 1 times negative 10 is negative 10. And our B is negative 3. So what times to negative 10 and adds to 3? Okay, so let's do negative. Remember, we take our A times C and we start from the ascending order. So let's do negative 10 divided by 1. You get negative 10. Negative 10, this number, and this number. If you add, you get negative 9. If you switch it, you do negative 1 plus positive 10, you get 9 again. So it doesn't work. So let's do negative 10 divided by 2, okay, which is negative 5. Negative 5 plus 2 is negative 3. And negative 5 times 2 coincidentally also times to negative 10. So remember, you can always switch the operations of your combinations. But you have to be careful. Because remember, a negative times a positive is a negative, okay? But when you do a negative, depending on what your combination is, when you're doing the adding or subtracting, you can change the answer. Okay, if we recall, negative 5 plus 2 would give us negative 3. But if we had decided to switch it, negative 2 plus 5 would get a positive 3. Now, although this would times to negative 10, it wouldn't add to negative 3. So that's why you have to be careful. So our factor here would be x minus 5 and x plus 2. Okay, let's try another one. X squared plus 11x plus 24. So, remember it's label A, B, and C. So our A times C is 1 times 24, which is 24, and our B value as is 11. So what times to 24 and adds to 11? Right away, I know. Let's go fast right here. It's x plus 3 and x plus 8. There we go. Okay. Now, every problem we did up to that point, all of them have all leading coefficients on our A value of of 1. Okay? Now, when the first number isn't 1, we have to do the A times C method. Okay, so what is the A times C method? Okay, the A times C method is the same thing that we were doing before, but since we were doing a 1, it didn't change. It would just be our C value on its own. So let's try an example. Let's try 6x squared plus 11x plus 3 equal to 0. Okay, so recall every time right away, a trick to learn is when you have a coefficient on your x, this is our leading coefficient. This is our leading coefficient. It's one with the highest degree. Okay? Always try and take it out at first, okay? If there's a possibility that if you can do a common factor, which we did in the examples at the beginning of the video, and you can take it out, do that because it'll make your life much easier. You always want to try to avoid situation. Here we can't do a common factor because these don't share a common factor. So we're going to do what we did last time, okay? So we are going to label our A times C and our B. So what times 2, so we're at A times C, 6 times 3 is 18, and our B is 11. So what times to 18 and also adds to 11? Okay, try our combinations. So 18 divided by 1 is 18. 18 divided by 2 is 9. Wait. If 18 divided by 2 is 9, 9 times 2 is 18. Okay, 9 plus 2 is 11, but 9 times 2 is also 18. So that means this will work as our factors. Okay, let's do it. X plus 9 and x plus 2. But no. This one we only do when the coefficient of 1. Actually, technically, with the method I'm going to show you right now, which is the A times C method, you can do it with any time when it is at 1. But it's the most annoying method, I would say. It takes a little more work. And I would say I'm lazy, so I like to do things efficiently. So when the coefficient isn't 1, and you can't factor a GCF out like we did in the beginning, we have to do something called splitting the B. Now what splitting the B is, okay? We get the factors, the combinations like before, but we rewrite it as 6x squared plus 9x plus 2x plus 3. Right away, we could have skipped all of this and we could have looked at the B and found combinations. Because if you look, the 9x plus 2x still add to 11. But at this point, we can do something called grouping, which is another factoring form. It's a factoring form when you have 4 terms. Before we were doing trinomials, 2 terms. Grouping is usually when you have 4 terms. Okay? So how can we do this right at this point? So always let's rewrite this. Let's rewrite this as 6x squared because they have to share a common factor plus 3x plus 9x. No, sorry, 2x. So I'm replacing it plus 3 equals to 0. Now we put parentheses around And we did like we did in the beginning. We take out the common factor. So let's take out a 2x from here. So 6 divided by 2 is 3x plus 1. And we take out a 3 from here. So it becomes 3x plus 1 equals to 0. Now at this point when you're factoring, you're doing what we did in the beginning. We're just factoring each one, grouping. Now if the way you did this right is if you can tell this and this have to be the same. So now we take the factoring from here. We do 2x plus 3 plus 3x plus 1. And if we FOIL this out, we're going to get our original term. So 6x squared plus 2x plus 9x plus 3, which is 6x squared plus 11x plus 3. Let's try another example. Okay? So 4x squared minus 15x plus 9. Okay. Remember, a times c. Let's start with a times c. So go ahead and try this on your own. Okay, I'm going to try it now. So our a times c, our a is 4 and c is 9, so it's 36, and our b is negative 15. So let's do our method of our combination. So 36 divided by 1 is 36. 36 to 1, don't do any combinations, adding or multiplying to give us a negative 15. So let's do 36 divided by 2, which is a 12. 12 plus 2, 14. 12 minus 2, 10. Doesn't work. Let's do 36 divided by a 3. Ooh, what did we get? So 36 divided by 3, if I'm not mistaken, is 12. Make sure. And this does work. Okay, so negative 12 and negative 3 give us a 36. Right? And they also give us negative 15. So we'll split the b. So we're going to do a 4x squared minus 12x minus 3x plus 9. Also, when you're splitting the b, make sure you put the ones with the ones you can factor. Because if we had put the minus 3x here with the 4x, we wouldn't be able to factor it out. So just make sure you can just recognize that. So now let's group. And let's take out a 4x. So we get an x minus 3. Let's take out a minus 3. So we get x minus 3. So our factors become 4x minus 3, x minus 3. Remember, these are the same, so that means we did it correctly. Okay. Now we're going to factor by grouping, which is what we just did right now. So let's just do some more practice. So 3x squared. You only group when you have 4 terms. So 3x cubed plus 6x squared plus x plus 2. So we group, take out as much as we can. So this becomes x plus 2. You can always take out a 1. You can always take out a 1 out of any factor, but it doesn't really change it, but we need it in this case. So this is our answer. Okay. Great. So this is in our grouping. We just did that before. You can always check your answer. So now let's do some factoring to solve equations. So these are all x's. Remember, depending on the degree you have, like if you had the x cubed, that means you have 3 solutions for x possible. You get like 3 answers. They're not all, like, they could all be wrong, but you can have 3 possible x values. So they're called solutions, possible solutions. So let's try everything we've doing with factoring. Remember, we have to set it equal to 0. I mentioned at the beginning of the video, but now you get to know why it's important. So let's do x squared plus 5x minus 14 equal to 0. When you're factoring, you always have to set equal to 0, and you're going to see why. So let's just do our factoring as normal. Now we're going to do it with a little more speed. So what times negative 14 adds to 5? I need to think about this. So let's do negative 14 divided by 2. Okay, I got it. So we can do x, because it's the 1, we can just do it right away. So it's x plus 7, x minus 2 equal to 0. So both equal to 0. We can set each of them equal to 0. So x equal to 2. So remember, zeros are the factors set equal to 0, and the factors are if they're not equal to 0. So remember, factors are always the opposite sign. And that's something you'll need to know for the rational root theorem, for multiplicities, for things in pre-calc. So yeah, so let's try another one. So we have 3x squared minus 21x equal to 0. So it's factor as is, so let's take out a 3x. So we get x minus 7 equal to 0. So 3x, each one is equal to 0. We divide by 3, x is equal to 0. That's our first x. Let's call it x1. Let's get this inside. X minus 7 equal to 0. X plus 7. There we go. We call this x2. And we can check these if we're correct. If we plug in our x's, the one that will give us 0 are the possible solutions. So 7, if you plug 7 in, that works. And if you plug 0, anything times 0 is 0. So that means these were both possible. These are both correct solutions. Let's try a cube one now this time. So x3 minus 9x equals to 0. Let's factor out an x here. So it becomes x squared minus 9. Ooh, is this something we recognize? This is the difference of squares. So we get x minus 3, x plus 3 equal to 0. So we set each one equal to 0. So once you do the math, you get x equals 0, x1, x2 equals to 3, and x3 equals to negative 3. Just remember, the degree always corresponds to how many x's you can get. So that's really it. I'm just going through it so you can try it. So now I want to focus on some factoring in fractions. Okay, so when you have something like a variable divided by variable, like something like this, x1 divided by x2, or like x plus 1 divided by x plus, this is called something called rational because it's variables in the top and the bottom, which means they have restrictions, which we'll talk about later, different video. Anyway, so let's try something like this. So if they had something like this, 6x squared minus 12x divided by 3x. How would we simplify this? So first thing I'd recommend is the factor. So let's do that. Let's do just that. So let's take out a 6x from here. So we get x negative 12 divided by 6 is a 2. And we have this 3x right here. So recognize the x's are the same. 6 divided by 3 is 2. The 3 goes away. So we just get 2x minus 2. And this is when they say simplify. So let's try another one. Let's try this one. So x squared minus 9 all over x squared plus x minus 6. So always with these, you want to factor and see what cancels out. So we have x minus 3, have an x plus a 3 all over. So what times negative 6 and adds to 1? 3 and negative 2. So right away, you can only cancel out if it's a multiplication operation. So right away, these cancel out. So we get x minus 3 all over x minus 2. So that's the answer. Is it? Let me see. Yeah, this is the answer. So now, that's basically a crash course, a very needed simplification for factoring because teachers really tend to make it more complicated than it needs to be. But here's a bunch of practice problems if you want to work on, which I strongly recommend. So these are for GCF. So 15x cubed minus 10x squared, 8y. By the way, I won't tell you if it's GCF. I'm just telling you just for reference. 8y4 plus 12y cubed and negative 14x squared plus 21x. Be so special patterns. So when you do this, post these in the comments if you get them. 5x squared minus 9 and x cubed minus 27. So here's some trinomials.